Good morning. Today I'd like to talk about these things. These are RGB LEDs. I've got two varieties here. This is the 10 mil package, this is the 5 mil package. And if you're buying these for yourself, I would get the diffused version, which is what these are. They have like sort of a milky color to them so that the colors blend better together and emit the same, like a mix of colors instead of individuals. What they are, what RGB LEDs really are three LEDs packed into the same package. So these would be useful for a case where you only have one mounting hole and you want to have a host of colors or a variable color, or just for things like decorations or whatever that can be changed to suit whatever the mood or the occasion. These things are really cool. They're not very expensive. You can get them from the usual suspects. These are a bit more expensive because they use quite a bit more resin than these, but these will work just fine. And the first thing you need to do before you start using these is figure out the polarity. Let me show you what I mean. So as the name implies, these things are three LEDs inside, red, green, and blue, RGB LEDs. And as LEDs, they can only be, current can only flow one direction. And we have to figure out what direction it flows in. So usually the long lead on a regular LED would be the positive. So I'm just going to put this test lead here. I'm actually going to spread the legs a little bit so that they don't touch, like this, and sort of like this. Whoops, bent that one all to hell. Okay, so now none of the legs are touching. I'm going to set my multimeter to Diode Check, which is here, like this, and now I'm going to touch the negative onto another lead. And there we go, 1.81 volt drop, and that is the red. See, the red is lit. I'm going to swap it to the next one. Green is lit, and blue is lit. So on this LED, the long leg is the positive. Perfect. Except you can't rely on that. These, my 5 mil LEDs, I'm going to spread the legs out again. So the long leg here, I'm going to put my positive on there, and then I'm going to touch this, nothing. This one, nothing. This one, nothing. What this is common cathode instead of anode, so common ground. So I put the negative on there. You got red with a very similar volt drop, which you would expect. Green and blue. So that's the first thing you need to do, is figure out your polarity. Now you could probably order them this size in common positive and this side in common negative, but if you're like me and you don't care, because I'm just going to be using these with an Arduino in the next video, and that just means you can activate them with high or activate them with low depending on which one, then it doesn't matter, you can order whichever. But if you have a very specific use case, like let's say you're replacing an LED that's already in a circuit, you do have to watch for that. So the next part is the same thing as another LED. Once we figure out the polarity, then we have to figure out the resistance we need. So let's do that now. So if you don't care about how this stuff works and just want to know the resistances to use, you can always cheat, like I'm doing right here. So this is an existing RGB LED strip, and you should be able to just make out, if I can hold this correctly, that there are three resistors here, 1, 2, and 3. 1 and 2, this one, these two outer ones, say 1, 5, 1, which means 15 with 1, 0, that's 150 ohms. And this one here says 3, 3, 1, if I'm holding that right. 331 means 33 with 1 0 is 330. So those are the resistors I picked to start with because these RGB LEDs are exactly the same as the ones we have I've shown you previously. It's just that these are in a surface mount package and mine are in a through-hole package. So let's take a look at what that gives us. So I have set these up so that they are in a position to be red, green, and blue, red, green, and blue, RGB, RGB, right? So these here are the 390 ohm because I don't have any 330 ohm resistors. So this one and this one are 390, but those two and those two are both 150. This is our 10 mil and our 5 mil, and you'll notice that our 5 mil here is linked to ground because don't forget it's a common ground, and our 10 mil is linked to power down here because it's a common power. So that means these resistors go into ground, these resistors go into power. So let's turn this on and see what happens. So there you go. It does look quite white on my preview screen here, but there are a slight tinge of blue. I find blue is quite overpowering sometimes, but you'll get away with it. It's close enough to white that most people won't notice, especially without the context of seeing blue around it. So this is passable. You can just copy someone else's resistances and you'll be fine. So if you get some of these and you don't want to fuss around with it, just know that the red is 330-ish ohms. Green and blue should be both about 150. And maybe if I had the lower resistance on the red, it would show up less blue. So you can actually order 330 ohm resistors. I just don't have any at hand. This is a good reason why you should have a big variety, a large variety of resistors. But yeah, so this works. And now if we can command a microcontroller to turn on and off individual colors, we'll just simulate that by pulling this. See, now it turned greenish. It might be swamping the camera. I don't know if you can see this. So that I turned off the blue. I can turn off the green. You'll see the red. It looks a lot more colorful to my eyes, but of course I'm limited by the luminosity that's being picked up by the camera. But same deal here. If I take off the red, put it back in. There we go. See, there's a little balance change. Turn off the blue. That's green. Okay, I do feel like 390 might be a little too high for red, but if you don't want to fuss with anything, just do it like this and you're good. But there is another way for those of us who are more into tinkering. Let me show you that now. Just one more side note. Before we move on. These resistors are intended for 12 volts, so you can actually run this directly from 12 volts, although this one here is running from 5 volts on the breadboard power supply. So those LED strips typically are 12 volts, so if you see a resistor value there, you can just use that. But the most important thing to note is that it's a ratio, so if you add more voltage, the colors will brighten up in a linear fashion, almost linear fashion. So basically, although overall the light will be brighter at 12 volts, the colors should be the same ratio. The mix should be the same from one another, pretty much. Close enough. I mean, if you're not in a tinkering mood, it'll be close enough for you. Now let's move on. So here I have the Tinkerer setup. This is if you want to fine-tune your colors and try to get it closer to white when all the colors are on. Because that technically should happen. When all the wavelengths combine, they should turn white or some facsimile of white. And here I have 3 variable pots. I have, they're all, I believe, 2K. Is that what they are? No, they are 1K. So they're 102, so 10 with 2 zeros, that's 1000 ohms. And I took 1K because our highest resistance in the operation before was 330, so I try to get as low as I can so we have enough variability to play with. Although still at 1K, these will be a little fiddly to work with. So, you know, tinkering, right? So I have it set up the same way. This is a 10 mil LED. So there's common power, and then here we have red, green, and blue. I made that all pretty for you guys. And then all these are linked, that's the wiper that's linked to red, green, and blue, and then the same end of each pot is linked to ground. So here we go, we're going to put the wiper to maximum resistance. So on these, the wiper is opposite the notch, so the wiper is here. So the resistance goes around in a circle like this, from this leg to this leg. So the wiper is here, so we connect here through the whole resistance back to ground. We have the most resistance possible. So I'm going to turn this on. And this is pretty dim to my eyes, but it's a little bluish. So if I turn them all to about halfway, see if I can do this without blocking too much. So here's the blue to about halfway, the green to about halfway, and the red to about halfway. So it's actually not too bad. I think we're dropping a lot of volts here. It's pretty close to white. I'm going to turn this down a little bit. Now we're going into the purple range. Oh, and if you go too far, of course, whoops, I pulled this out completely. If you go too far, of course, then there's no resistance here. So this is just running straight 5 volts to this, which is actually probably heating up my voltage regulator here. To give it a little bit more. See how it's much redder now? I'm not sure if you're actually capturing that. I guess you'll have to trust me. It's pretty red. Turn this down, and you'll see that even these 1K pots are not great. Don't have very much variability, but of course if you go all the way to the end, then it'll actually turn that color because you have no resistance. So yeah, this is fun to play with. And so once you have it all set up, so let's say I find a nice color mix I like, so a little bit, let's say I want it more blue, so it's like that, it's almost blue. What you would do then is turn this off, unplug these wires, and just measure the resistance between here and here, so across the pot, and then you would figure out what's the closest standard resistor to that. Or you can even put these pots in your circuit and just have these pots to vary kind of the mix of color as you go along. So there's a lot of things you can do with this. So I think that should just be about enough to get you guys going and wanting to experiment with these things. The next step, at least to me, is to add a microcontroller. I'm going to start with an Arduino Uno, so if you have an Arduino Uno, go ahead and get that ready for the next video, and we'll see what we can do with the Arduino Uno. Eventually, though, I have a different plan, which I might cover next video, or it might be in part 3. Either way, though, thanks for watching.